Hello and welcome to part 5 of the video series where I finally fully assembled the Quadratrac transfer case. In part 4 I detailed all the parts that will go into the rebuild. So all the detail is there in the video, and in the description of part 4 there's a list with links so you can find all the parts if you need them. And there is a lot of ground to cover in this assembly video, so let's get right to it, and we'll start with the assembling the differential. I have a few of these differentials to choose from. Most of them are junk. This one seems to be in fairly good condition, so we will build it and see how it goes. You can see on the cone friction face is relatively smooth. There's only some light scoring, and that's probably the best we can do. So alright, and to assemble the differential, we're looking at the front side of the differential case sprocket, and we want to assemble the side gears. I've kept them in the same order so they'll go back in the same position they came out. And we begin by inserting the cross shaft into the case sprocket, and then placing this wear component, and then the first side gear. Note that there's a hole here in the cross shaft that will accept a locking pin that goes to this hole in the sprocket, so make sure that's inserted correctly. Next comes the other side gear, and its little spacer. Then align the shaft so that the locking pin will drop through, and that's not captured, it will fall out the other side, so be aware of that. It will eventually be captured by bolting on the front and rear flanges. Separate the side gears to their respective sides, and then I have kept all the pieces that came out in the same order with a zip tie, and so we'll now reassemble them back into the case in the same order they came out. So first comes the side gear. All these parts have been pre-lubricated with TCL1, proper lubricant for the case, and then drop in the first side gear, the front side gear, and then of course on disassembly we discovered that the original cones splines, inner splines, were rather worn, and so we need to replace those. There's a thrust washer on the back of the cone we need. So we'll replace this with the cones from BJ's that we showed in part 4. There are the brand new BJ's cones. You want to make sure all these friction surfaces are lubricated before assembly. And I've lost my side gear. Alright. So with the side gear in, the cone will go in and hold that into place. And then the large thrust washer, and then the cone or Belleville springs, all lubricated nicely, and they go concave side toward the cone like this. There's all three, and then there's a small thrust washer here on the flange, so we want to keep that here on the flange. And then we need to assemble the flange in the same orientation that it was removed from the housing. And of course, hopefully you've marked these before you disassembled. If you have lost your mark somehow, you can usually see where the locking pin hole has left a mark on the flange. I don't know if you can be able to see this. There's a small little circle there, and that's where this hole has made a little mark in the flange, and so that's where we will reassemble it. Make sure everything stays centered as you put the flange on, just like that. Now we simply bolt the flange on. We only want to do this finger tight. Now once those are finger tight, we can flip the assembly and do the other side. Be careful that the locking pin does not slide out of the case. And there it is. It's trying to slide out, and it's back into its bore. Now, same procedure for the rear of the assembly. Alright, we place our side gear first, and we have our worn out cone, original equipment cone. And our thrust washer will go into the brand new cone from BJ's. Again, lubricate all these friction surfaces before assembly. And then goes the thrust washer, the 3 lubricated bevel springs concave toward the cone. We'll leave the small thrust washer attached to the flange. Find the circular mark from there, that one you can see pretty well, from the locking pin hole, or use your alignment marks that you made previously. Then the bolts go finger tight again on this side. Now next is an important step. The reason you only tighten these bolts finger tight to this point is that the splines of the cones and the side gears are not aligned, which make assembly very difficult later if you go ahead and tighten these bolts down. So what you can do is then take the rear output shaft to align the rear elements, and just turn everything a bit until it drops into place. Same with the other side on the front. Take a front output shaft, turn things until the shaft will seat all the way home. And now your cones and side gears are aligned, and therefore when you tighten these bolts you can pull the shafts out, and everything will remain aligned, so the final assembly into the case will go much smoother. So what I do is I pick 2 opposing bolts and tighten those down. You can see maybe there's a gap here. The springs aren't fully compressed yet. So let's gradually snug up 2 opposing bolts to evenly compress everything. Okay, now the flange is all the way home, and I'll snug up the remaining bolts. And then I'll repeat for the other side the same. Just check that the flanges have completely seated to the case and there are no gaps. snug these up all a bit more. And then using a torque wrench, torque these bolts to 27 foot-pounds. And of course you can hold this into a vise to make this a little easier, or if you want to do it on the bench, simply hold the opposing bolt, or one of the opposing bolts while you torque the other side. Now, in principle, you have, by doing it this way, you have torqued both sides already. However, I will flip it around and hit the front flange bolts with the torque wrench as well. Okay, both sides torqued to 27 foot-pounds, and the shafts should be able to slide back out. But while we have it assembled this far, let's also do one more step, which will be it's called a torque bias check, and what it measures is how much torque it requires to break free the friction cones and make them slide. So you basically twist the two shafts in opposite directions, see how much torque it requires to make everything slip, and it should land somewhere between 80 and 170 foot-pounds. Of course, now we have brand new cones from BJ's, and they're freshly machined against a slightly worn case. So I'm not sure what to expect, but I want to get a baseline measurement. I expect it will possibly change over time as the new surface wears against the old surface. But anyway, I want to see where we start, so we'll give that a try next. So I have a yoke and my yoke holding tool, and then I took another yoke and I bolted it to my 3/4 inch drive ratchet in hopes that we can hold these well enough on the bench to actually do this measurement. We'll start with the torque wrench at 100 foot-pounds and see where we are. Let me reposition this a bit. And I will snap the torque wrench into the yoke holding tool, and of course, since I'm not actually applying torque to the center like on the nut for the shaft, so the torque I measure will be slightly wrong by this being offset by a couple inches, but we're just looking for ballpark number here, so that will be fine. Alright, let's see if we can do this. Okay, 100 foot-pounds did not make them slip. Okay, I was unable to do this test on the bench, so I got it down to the ground to get more leverage, and the cones slip at about 120 foot-pounds. So it's good, it's in the correct range. We'll probably run this for a while in the vehicle and then test it after several miles. One last thing I'll show while we have a good view of it is we have the rear output shaft and the locking collar. This is for the emergency drive, and this is the shift fork. So this is what happens inside the case, when you shift to E drive, the fork moves the locking collar and it locks the output shaft gear to the flange, the rear flange on the differential case. And then the shaft cannot spin relative to the case, which means the cones on this side can't slip. It also means the side gears on this shaft can't turn, which means that the side gear on this side also can't turn. So this is then locked up all the way through an emergency drive, and it's not a differential. So that's how that works. Okay, next let's get the front half of the case assembled. What I've done since disassembly is to simply degrease the case and clean it up, make sure all the surfaces are smooth, make sure the bores don't have any burrs so that the bearings and seals will slide in. And on these cases there's a couple of threaded holes that are not used in a CJ application, so just put a couple bolts in there to protect the threads in case I want to use those for something. And then I chased all the threaded case holes with a tap. Otherwise, clean it up and it's ready to go. We will first go after the needle bearings with that support the drive sprocket and the differential. I give the details of those bearings in part 4, so I won't cover that again here. And basically we have 2 of the same size bearings that go here and here, and we will drive those in with the driver. I select a driver that's slightly larger than the hole, so when it comes all the way down, the bearing will be flush. So first, go ahead and set your bearing there in the bore. This is the one that was very difficult to get out. Hopefully it goes back in a lot easier. Make sure it's driving in straight. And you can feel it very solid when the driver hits the case, and bearing is flush. It's good to go. These bearings have been pre-lubricated with TCL1. Now let's move to the next. Simple as that. Then the needle bearings are in. We'll move from there on to the annular output shaft bearing, which goes here. The annular output shaft bearing is located in this bore with retaining rings that go in these 2 grooves. We have then the 2 retaining rings we took out. They need to be a certain thickness in each groove. The inner ring that goes to the bottom groove in this case should be between 0.06 and 0.063. This one is 0.063. This one is 0.063 as well. So in this case it doesn't matter. I'll go ahead and get this ring installed. Okay, there we have one retaining ring installed for the annular bearing. Now, about the annular bearings, I explained this in part 4 of the series, that basically these bearings are no longer available because they're a special bearing. I won't go into the details again here, but I mentioned that I had some custom bearings made, essentially. So what we started with, I worked with a bearing manufacturer, and we started with a Koyo 6206Z bearing, which is a standard metric bearing with metric ID and OD. The problem is this case bore is measuring 2.5 inches, so we need a customary or an imperial OD. So I did a low volume order, so it would have been very expensive to have them actually manufacture new bearings, which is why we started with the Koyo. It's slightly under 2.5 inch on the OD, fits the shaft perfectly on the ID. Has a shield on one side, and that goes toward the inside of the case. And basically what they did is they machined a nice sleeve and then press fit that onto the bearing. So it's a nice tight interference fit, and the thickness of the sleeve matches the thickness of the bearing, so this should drop into the case and work very well. I talked with several folks in the sort of bearing industry and industrial machinery industry that are familiar with this. Maybe if there's some concern about a sleeved bearing, if that's okay or not. It seems to be that it's a very standard practice. My other option was to maybe make a shim inside the bore, so I like this much better. I'm not worried about it, I'm going to run it. So anyway, let me lubricate this bearing with a TCL1, and then we'll drop it in. Okay, here we have the lubricated bearing, and I had requested that they make the sleeve to measure 2.496, which is what I measured on the original Federal bearing. When I checked these when they came in, they measured 2.495, so I think 1/1000th difference is acceptable. So let's get these installed. So again, the shield goes to the inside of the case. I cleaned up that bore, so now the bearing just drops right in. It doesn't need to be driven in. And then the next step will be to put in the final ring, retaining ring. And there we have it, one annular bearing installed. So this is exactly the same procedure on the other side of the case for the rear output shaft. So in the interest of time, I won't show it again, but it's the same snap ring thicknesses, same bearing, and just repeat that, and you'll have the other side done. Okay, now that the bearings are in the case, we'll put in the shaft oil seals. I like to do those last, right before final assembly, so this side of the case is ready to assemble essentially. So we'll go ahead and put the seals in. And the front output shaft, there's a oil seal that goes here, and then on the transmission input shaft there's 2 seals, and one goes one way and one goes the other. And the way these seals work, there's a little spring in there, we'll focus, that squeezes the rubber around the shaft that it goes around. So that side goes toward the fluid you're trying to seal against. So in this case, we want to keep one of the seals is for keeping the transfer case fluid in, so it'll go down like this. And in the other case, the idea is to keep transmission fluid out, and so it'll go up like this. And then it's important to note that there is a weep hole, and that actually ends up between those 2 seals. You can see here, and you can see this groove is not sealed by the gasket, so that way if you have a leak on either side, it will come out of this weep hole and drip here, and so you'll know you have a seal leak. Now, generally speaking, this red material, or in this case the green material, is made for making a good seal to the case. But since these case bores are a little bit old, maybe a little bit beat up, I'm going to add a little bit of sealant just in case. And the sealant I'll use is the same I used for the low range unit freeze plugs or taper plugs, is some of this Vibratite 550. Now we'll apply that just using a thin smear where the seal will go. Just a little small amount. Go around the inside of this bore. And just use a very small amount. You don't want to end up plugging the weep hole with whatever sealant you're trying to use. Of course, you can ensure that by putting in something through the hole. Make sure it's open. Looks good. Now, let's install the first seal. We'll do that with the spring facing into the case. So that side, where you see the spring goes into the case like this. And then for this, we need a driver that's smaller than the case bore, so we can drive it all the way where it needs to go. Now what you want to do is drive that seal past the weep hole. Make sure that's open. And it should essentially be then flush on the inside here, close. So we can drive that just a little further. Make sure that weep hole is all the way open. I'll add just another thin smear of Vibratite. And then we'll drive in the second seal. And for that I'll use a driver that's actually larger than the bore, so it'll drive it nice and flush. Feel this seal driver go flush to the case, and that's it. But I like to come with just a small amount of the TCL 1 lubricant. Get these seals nice and pre-lubed, so hopefully we don't damage them when we assemble everything. Alright, that's it for the transmission shaft seals. Let's move then to the front output shaft seal. We'll apply a thin smear of the Vibratite 550. Okay, then the seal, the spring, is on this side, and it goes toward the inside of the case. Again, seal driver slightly larger than the bore. Okay, then come with A little of the TCL lubricant. Get it all over the rubber part of the seal. That's basically it for seals. One last check. Make sure we didn't plug up the weep hole. And there you see the end of the, you can see the end of the punch. There we go. So weep hole is open. Alright, and so there's the front of the case with the bearings. The seals are installed. We'll set that aside and it's pretty much ready to go. Now let's move on to the back half of the case. Now what I haven't shown you is driving in the needle bearing. Is exactly the same as the other two in the front half of the case, so that's in. And the annular bearing already in, just like I showed you on the front half of the case. And just since this is a last needle bearing is a different larger size, we'll go ahead and put that in. Okay, so here's that one larger needle bearing. It needs to be driven into the back half of the case. Good, there the large needle bearing driven flush to the inside. And then since there's a bit more to do on this side of the case before it's ready to assemble, we'll not do the oil seal here yet. We will first assemble the emergency drive shifter mechanism. Okay, next let's assemble the emergency drive shift fork and shifting mechanism into the rear half of the case. The shifter fork has nylon pads, and I have old ones that are reasonable, but I will use new ones simply because the old ones do not fit very tightly. They can easily fall off, whereas the new ones actually snap in and hold. So when you're putting this into the case, it's easy to drop the shoe into the case. So the new ones snap in and hold a bit more firmly. So then the emergency drive collar has a groove cut on the left side and not on the right side. It's otherwise symmetric. I'm not sure the purpose of this groove. It doesn't seem to actually have a purpose, but it's usually what I find is installed to the rear of the case, and the rear of the case is this direction. So I'll put it back that way. I have sometimes found it installed in this direction, but I usually install it this way. Matter of fact, you can see just a little bit of wear on the teeth here. So that's the side that engages the differential. So that's the way this one has been running in the past. So we'll put it back that way. So in order to do so, you want to install, first orient your fork. So on the fork there's a long side and a short side that go over the shifter shaft. So the long side, which is this one, goes toward the rear of the case like this, and the groove goes toward the rear of the case. So you assemble the locking collar into the shifter fork as an assembly, and then put that into the case as one piece, and do that by reaching through the case to support it, the collar, so it doesn't fall out, and so the nylon shift pads don't fall out. So for now you can just rest that to the bottom of the case. And then the next step is to install the vacuum actuator. We're going to use the new replacement model from BJ's. There is an O-ring, it'll be hard to see. It's installed into this groove closest to the actuator. And I have a little bit O-ring grease on that already, and then this larger groove is for the small spring that goes here to hold the whole assembly into the case. And of course you can assemble this case in a different order than I have, but make sure that this actuator goes in before you install the rear output yoke, because this will not slide past the yoke, so this should go first. So slide the actuator into the case and through the shift fork. But don't slide it past the hole here. This is where the detent ball and spring go. So this is the spring. Insert the detent ball, then compress with a small punch or screwdriver. And slide the actuator over the detent. So as you seat the O-ring, the detent ball should pop into the groove. If you push the housing of the actuator too far forward, it will cover the snap ring, the E-clip groove, so slide that back. If the actuator body is too far into the case, it will hide the E-clip groove that's used to retain the shift work. So if you need to, pull the actuator housing back to expose this groove that receives one of these E-clips. Like that. Then shift the fork to that E-clip, and it will expose the second groove in the shaft there for the second E-clip. Like that. Then the fork is captured, and it should shift freely. You can hear should be able to hear the detent ball hit the second detent position. I'll go smoothly, and here you can see the actuator shaft coming forward, and that will hit the four-wheel drive switch or emergency drive switch, which we'll install later. Here's a reproduction of the original steel plate in stainless steel. And before installing the cover plate, drop in the retaining spring that fits into the groove on the actuator to keep it into the case. Make sure that seats into the groove in the actuator. Then this is the O-ring from the BJ seal kit or the Crown seal kit. Lubricated with some O-ring grease. The cover plate can be installed like this, and I will secure that with a 1/4 5/8 inch long stainless steel screw with an internal tooth lock washer and a flat washer and a bit of anti-seize. Tighten those to 8 foot-pounds. Then we need a vent for the case, and I'll replace the factory vent with this elbow. It's 1/8 MPT thread to swage lock, which is a compression fitting. For the pipe thread, I will wrap a bit of Teflon tape. A little bit of Teflon tape on the threads. This fitting should require 1/2 inch wrench, but that doesn't fit. I point the elbow roughly here because that's the way my vent tube will run, and then in order to adapt the 1/4 inch rubber tube that I used as a vent, I'll need a hose barb into the compression fitting. Then in the future, if you'd like to remove your vent tube, this stays in one piece, and you have your rubber tube attached to this side. And that's it for the emergency drive shifter assembly. Move on to the next step. Okay, the rear half of the case is almost ready to reassemble, except for the output shaft seal, which you can either do now or later. Once the whole case is assembled, I like to go ahead and do it now. But if you do it at this point, just be aware that the side cut speedometer gear needs to go in before the seal. At this point, there's no shaft to align it, so you just need to drop it in. The gear has a shoulder here on the left side, and that goes into the case like this. So we'll go ahead and drop that in. It's going to be loose. So if you do it this way, and you really shouldn't install the speedometer gear yet, because it can't mesh properly with the side cut gear. So we'll just leave that in there for now, and then install the shaft seal. I won't show that on camera because it's just like the front half of the case, so I'll do that quickly, and then we'll move on to the next step. Now with the side cut speedometer gear installed and the shaft seal installed, you want to go ahead, if you've installed it this way, go ahead and install the rear output shaft, and that will align the side cut gear. Insert that from the inside. It needs to mesh up to the locking collar for the emergency drive, and come through both the speedometer gear and the output shaft seal, and pull that up, make sure it's come all the way. And what that will do, it'll bring the speedometer gear with it, so the speedometer gear is then not aligned to where this gear needs to mesh with it. So anyway, pull up on the shaft, make sure it's all the way forward against the annular bearing, and then you can just press the speedometer gear down on the shaft with a small screwdriver or something, and you'll feel that seat all the way down. And then this will mesh. And to check the alignment, just rotate the shaft, output shaft a little bit. You should see the speedometer shaft rotating. It should indicate that everything's aligned well. And then before assembly, you want to lubricate both this end of the shaft with threads and a bore and the gear itself. Okay, to finish up this installation, here's the speedometer cable adapter. That has a little shaft seal. This is a replacement that seats down into the adapter housing like this. It's a snug fit, but it will go. Okay, so that's been lubricated with some O-ring grease as the shaft. And then I don't know exactly what these threads are. They don't look to be pipe thread, but nonetheless, I will put a little bit of Teflon tape to seal those threads. That's a 7/8 inch. And then this gets torqued to 25 foot-pounds. Alright, now that the speedometer gear is all together, I like to throw a cap on there to keep everything clean. And then what we can do is go ahead and put the yoke on this side. And to do that, I like to lubricate the sealing surface that goes into the seal itself. This is just a double cardan style yoke that I replaced the regular 1310 yoke since I have a double cardan drive shaft on the rear. So this is a 10 spline yoke and a 10 spline shaft. So what's happening here is the dust shield is rubbing against the case a bit. So what we'll do then is this is a 2-inch socket. We'll bend that dust shield out a bit. Maybe it's a little straighter now. Now it rotates freely. So then next goes the rubber seal, which has been lubricated with a little O-ring grease. Then goes the washer. These are all the new ones from BJ's. And then the lock nut. That's 1.1 inches. And this will eventually get torqued, but for right now we just want everything to hold together. Okay, that's one output shaft yoke installed. The bolts are already installed. These are ARP high strength equivalent to grade 9 bolts. They're 5/16 24 and 1.25 inches long. They are captured by the little dust shield there so they don't fall out. Okay, that is essentially as far as this case gets assembled before we start to put in the drive sprocket and differential and chain. So we'll reset and do that next. I'm going to assemble the main drive sprocket and the differential into the rear half of the case with the chain. So put the back part of the drive sprocket up, which has the this output that meshes to the low range unit. And of course this is the emergency drive side of the differential, so that goes to the back half of the case. Put these on the bench. Use about a block of wood. This is a 2x4. You want to make these roughly a similar height. And then we have the brand new chain from BJ's, and we'll put that over the differential and drive sprocket. Alright, and then move the differential away to tighten the chain. Make sure the chain gets seated down into the gears. Alright, push the differential away from the drive sprocket. Make sure the chain is fairly even and snug. Alright, and then before bringing the rear case onto the gears, there's a plastic thrust washer that goes here, and it always wants to fall off when you assemble it, so I've put a thin layer of wheel bearing grease, something fairly sticky. Hopefully hold that in place until it can rest here on the drive sprocket. So once you have this all ready to go, pick up the case, start the output shaft into the differential. Then align the drive sprocket to the bearing over here. You may need to rotate the shaft to get it to align to the differential. Like that. Get a last look at your thrust washer before you send it home. This one looks good. So the needle bearing on this side hasn't slipped over the differential yet. It's the problem with the tight chain. Everything fits very snug. Now it's started. So you can use a dead blow to send it home. And then to sort of lock all this into place a bit, we'll have the planetary carrier out of the planetary gear set for the low range. This one's going to have low range. Place that onto the main drive sprocket. Then that gets captured by this snap ring. Want to make sure the snap ring gets seated all the way into the groove. Like that. Now with the snap ring installed, your thrust washer shouldn't fall out, so hopefully we can turn this over and then work from the other side. In preparation for sealing the case halves together, I'm going to clean off this sealing surface with some solvent. Next we can install the O-ring that came in the BJ seal kit, or the crown seal kit. It will seem like it is too long, but it will eventually go where it needs to go. So you can see here, it appears to be too long. just hold it at both ends of this bulge. Slowly work it in. There. That pushes it back around the groove and everything fits. Now what I like to do in this case, to seal the case halves, it's a real pain if these things leak after you get them on. So what I'm going to do when there's a O-ring groove and an O-ring, like in this situation, I like to add a little bit of this gasket sealer. It's the same thing I use to seal the PTO cover on the low range unit, and it sticks to rubber, cork, metal, whatever, and give it a better chance of making a good reliable seal. So I'll paint just a very thin layer around this case half right over the O-ring, and then I'll do the same for the other case half. Wait 5 minutes and to let it cure, and then come back and assemble the case halves. Okay, now we have Differential on the sealing faces of both case halves. It's been curing for about 10 minutes, so we can proceed to put the front output shaft into the differential. Since we aligned everything earlier inside the differential, that slides right in. And then, this is very important, there's a thrust washer. It fits here, it rides on it rides on the differential, and then eventually on the annular bearing on the other side. So assemble by starting the output shaft through the left side. Try to align the drive sprocket to the bearing on this side, on the right side. Okay, that started. Now the needle bearing needs to go over the differential on this side. I think it started already. So once that's all started well, you can help it on home. And then we can screw the case together. This is have some bolts here. There are two 5/16 18 by 3/4 inch. There are 8 3/8 16 by 1 1/4 inch. That's most of them. There are 2 3/8 16 by 2.5 inch, and there's 1 3/8 16 by 1 3/4 inch. And we'll take a couple of the 1 1/4 bolts and start drawing this case together. Once it's started to pull together, then I'll flip it over so you guys can see it a little better. Okay, that should hold the case together well enough that I can move it. I will also add that all the stainless steel bolts have a bit of silver, Loctite silver anti-seize, just to prevent any galling of the stainless bolts. Actually, before I move the case, why don't we go ahead and install the front output yoke. So just like the rear output yoke, put a little bit of TCL lubricant there. The seal's already lubricated, so we can drop the yoke on. I want to confirm that the dust shield doesn't drag on the case like the rear one did. Seems okay. Okay, let's continue installing the bolts. You can see that the case halves are pulled together. I can see just a a minute space still, so we'll draw that together. The remaining 3 3/8 bolts and the 2 5/16 bolts hold on the either the cover or in this case the low range unit. So it is now time to pull out the rebuilt low range unit that we did in part 3 of the series. Okay, here we have the low range unit that we rebuilt in part 3 of the series. And here we have the O-ring from the BJ seal kit installed in the O-ring groove. And then both mating surfaces have been I've applied some gasgascent, and it's been curing about 10 minutes. So now we can finally fully reassemble this case. Let's place the low range unit over the planetary. You can use your fingers to sort of spin the planets a little bit. Help this drop on, like that. Then I have about a 1/4 inch gap here. It's not all the way in. You can use maybe elevate this side to use the yoke to turn the whole assembly, and then use the shifter here to mesh the gears a little better and find the spot where it goes home. Okay, after shimmying things around and turning the yoke and shifting the low range unit back and forth a few times, it's dropped home. Now the mating surfaces are sitting where they should. And now we can install the final bolts. You can see the positions of the other 1 3/4 3/8 bolts. Here's the 5/16 3/4 inch bolts. And then the 2.5 inch bolts go here. So you can see those two positions are the 2.5 inch bolts, and then the 1 3/4 3/8 bolt goes right here. Alright, and while we're on the top or rear of the case here, I have a few drain plugs to install. So this is for the fluid fill, so I'm not going to fill it with fluid yet. So this is stainless steel plug with a magnet. I'll just temporarily store that there to plug that hole, keeping dirt out. And then this is the drain plug, so this is going to get fully installed, so we'll go ahead and put a little bit of Teflon tape on this one to seal it. So like this. Also a stainless plug with a magnet. So it needs a 3/8 hex. This is a 9/16 hex. We won't tighten that one yet. And then the last plug is for the chain inspection port, which brings me to the next point. Let's have a look at a chain tension with a chain inspection tool with a brand new chain. So I can already tell that it's even more difficult to push the tool in to even get it to start threading. So that's probably a good sign. Okay, now we can see that the plunger protrudes from the chain inspection tool, indicating we have a good chain. And that's currently extending almost 3/8 of an inch, not quite 3/8 of an inch. So we'll use that measurement to figure out how to get this, check the chain tension without this tool. Just like the other plugs, we'll wrap with Teflon tape. Okay, like this, and this plug requires a 1/4 inch hex driver. And the chain inspection plug gets torqued to 12 foot-pounds. And the drain plug is torqued to 20 foot-pounds. So the fill plug for the reduction unit is also torqued to 20 foot-pounds, but we'll wait till after we fill fluid with that. And the large fill plug here for the main case, also 20 foot-pounds, and we'll do that once the fluid has been filled. The 2 5/16 bolts on the hold on the reduction unit get torqued to 10 foot-pounds. And then all the remaining 3/8 bolts are torqued to 20 foot-pounds. Okay, that's it for the bolts. Okay, last couple of details. There's the 4-wheel drive switch. So now that the bolts are torqued, I can put in the switch. And then that switch gets torqued to 12 foot-pounds. Okay, 12 foot-pounds for that. And then the yoke nuts need to be torqued to 120 foot-pounds. So I have the yoke tool here, breaker bar here. Let's see if I can get that torqued to 120 foot-pounds. Okay. So I'll do the other yoke off camera, and that is pretty much it. Fully rebuilt Quadratrac 1339 transfer case, ready to go back into service after 40 some years of neglect and abuse. Now, I will say that this is about the most expensive way to rebuild this case, right? So I replaced almost everything with brand new parts that was possible, but of course you don't need to necessarily do this if you have good parts that you take out and put them back in. Save quite a bit of money, right? If your bearings are good, no need to replace bearings. I just wanted to go in as full detail as possible in case you lost the little E-clip or the taper pin, whatever. You'll be able to find a replacement. And so I will just mention one last thing. I did find replacement springs for the detent ball for the low range shifter, and for the emergency drive shifter, and also for the little tiny spring under the emergency drive cover plate. Those just came in today. I'll just add them to the rebuild list in part 3 and part 4 in the description of those videos, so you can find those there. And okay, that's it. I know it's been a long video series, but I think we're finally done. Now we'll put this in the Jeep next. Thanks for watching.